Hey everybody, my name is Kunal Anand, and my talk is called Signatures Are Dead, and it's going to be a fast introduction to runtime and language security. So a little bit about me. I'm the co-founder and CTO of a company called Prevoty. I love security and data visualization. Quick note on Prevoty, we've built a solution that can monitor and protect applications and services, web services, from real attacks without relying on any signatures or definitions. To give you a sense of our journey, and our scale, we work with the largest payment processor in the world. We work with many stock exchanges and also several top 10 retailers. We've gone through about 3 Cyber Mondays now with several retailers, and I can tell you it's pretty fun. It's great to be here today. So I'm going to start by giving you a current state of where we are today from a security perspective. So when we think about security, when we think about cybersecurity, we think about it in terms of 3 pillars: the network, the endpoint, and the application. The network, primarily thinking about perimeter-based defenses like firewalls that are looking for zeros and ones. The endpoint, we're thinking about solutions that can protect servers and desktops from rogue processes. And then the application. It's the heart of everyone's business today, web applications and services. So analysts like Gartner claim, and they make these statements, that 80% of apps, 80% of attacks target applications and services. So the attackers have shifted their focus away from the network. And just from our own customer data, we sampled this from one of our retailers. They see about 5 million security incidents a month. And here's the thing, they're already doing code reviews, and they already have a web application firewall and a network firewall in place. And yet they're still seeing 5 million plus incidents land into the application every single month. So why is that? Well, the first is that at this point, networks and endpoints are commoditized. And so here's what I mean. More and more apps, as get developed every single day, are developed devoid of a network. They're not thinking about an endpoint. They're getting containerized, they're getting virtualized. And if you think about it, the network and the endpoint are orthogonal to the application. The application is running on an endpoint, and the network delivers bits and information to the endpoint, which is running the application. They wrap them, but they can't necessarily see what those things are doing on the inside. So how can something like a firewall that sits at the network stop something like a SQL injection, which is fundamentally happening between an application and a database engine? And the second thing is that current defenses are relying on pattern matching. And when I talk about pattern matching, I'm talking about things like regular expressions, signatures, blacklists, virtual patching. And there's a high cognitive load to maintaining these things. In a previous life, I was running security for the BBC. And in my role over there, I had to figure out a way how to keep track of different firewalls, different configurations, and different rules for each individual property. And what's pretty crazy is that it's trivial for fuzzers to go right through solutions like regular expressions. I'll show you a quick demo. So let's take something trivial like this, the simple piece of JavaScript that's going to pop up an alert, hey NYC. So what I'm going to do is I'm going to shift over to my web browser. This is a tool that we wrote that just can fuzz JavaScript. So we see something like hey NYC, and it can do it in real time. So we can turn it into something like hi NYC. And this is going to do the same exact thing that we just saw before. It's going to still evaluate and execute JavaScript, except there are no letters whatsoever in here. And the problem today is that we're relying on a solution that is entirely dependent on regular expressions and signatures to do this work. So I pulled this signature directly out of a popular web application firewall. And this is a regular expression. It's trying to look for JavaScript. And it's powering many, many different firewalls today. The problem is your bad guys today have access to these same payloads. They can see the same scripts. So the other thing is that there's a plethora of free software out there, and with enough motivation and access to bits, you can also be pretty dangerous. From a vulnerability management perspective, we're scanning a lot today. We know where we have deficiencies in our code base. We know where there are problems, but it's really difficult to practice vulnerability management and to build a secure software development lifecycle. It can cost a lot of money. Going back to that example of that retailer, they told us that it costs $40,000 to fix one SQL injection in production. $40,000. They're running a vulnerability management tool. Someone has to qualify it. It's got to go to a dev team. It's got to get developed. And it's got to get tested. And eventually, it makes its way out to production. And what we found is that it's a pretty delicate balance practicing a software development lifecycle, because the moment you try and get something in place, something else goes out of place. And it's really hard to manage development, security, and operations and test issues all at the same time. So I've painted a pretty bleak picture so far, and now I'm about to show you something that can help, which is what we've built at Prevoty. So what we've built is something called Runtime Application Protection. And what that means is we've created a series of plugins and agents that can just be dropped immediately into an existing application without requiring any code changes. The idea is that you don't need to create or write new code to bring security into your application. And we've been able to bring this approach to solutions like .NET CLR, Java's virtual machine, and even scripting languages like Ruby, Python, and PHP. And the interesting thing about this is we use common instrumentation and profiling APIs to hook the underlying infrastructure. And again, this isn't a network firewall. This is not something that's sitting at the perimeter. This is something that you could drop into an application. So some folks consider this as a firewall that lives inside of the application rather than something that's outside of the application. And the benefits that you get out of this is security travels with the application. It doesn't matter if the app is containerized, virtualized, deployed to Big Iron, or deployed to a cloud. If it's in a staging, production, or even in a development environment, security is always with the application. And by living in the app, you have access to context, and I'll show you that in a quick demo. And the other thing is that it's real attacks. These aren't theoretical. By living in production, by breathing in production, you're seeing actual malicious payloads, not something simulated like a vulnerability tool. When it comes to visibility, we want to be able to show off the intelligence of who, what, when, where. So the who could be not just an IP address, but also the user session. Again, by living in the app, you can pull out all sorts of information like the user ID, other session information related to that. And the other one that's really powerful is where. So where did the SQLi originate from? And I'll show you that in a quick example. Now, the other component that I wanted to dig into is language security. And the question is really, what if you could calculate the side effect of an input? So what if you could figure out what an input is going to do? And when I'm talking about an input, I'm referring to an HTTP variable, a database query, or an operating system command. And so with an HTTP variable, it could be something like cross-site scripting. With a query, it could be SQLi to go on and do something like data exfil or data breach. And with a process, it could be something like command injection. Well, it turns out if you actually do language analysis by building things like tokenizers, parsers, basically a compiler for each one of these things, you can protect against these kinds of attacks. So let's take something like a SQL injection. You can parse commands, data, tables, but you can also do things like expression evaluation the same exact way a compiler would. So you can detect things like tautologies, something like 1 = 1. But you can be a little more sophisticated than that. You can catch things like sine of 1 = cosine of 0, or 1 + 1 = 2, mathematical operations that the attackers are now using, rather than trivial things that are being used by signatures and pattern matching tools. So you're probably wondering at this point, so what's the trade-off? Is performance somewhat of an issue here? And the answer is no. There's no trade-off with performance. In fact, this language security approach is much, much faster than pattern matching. I went ahead and I pulled all sorts of patterns from existing technologies, whether it's firewalls, perimeter-based defenses. And the best part about this is that LANGSEC exceeds the common approaches that are out there today by several orders of magnitude, having to shift this to a logarithmic scale even for these other approaches to show up. So I'm going to go into a quick demonstration right now of what Prevoty is, how it attaches to an application, show you before and after. And then if we have some time, might be able to show you a little bit about LANGSEC as well. So I'm going to shift back over to this application. So in this particular application, it's called Acme. And in Acme, we have a simple form field that allows you to search for dummy stock information. So you search for something like Google, you get back data for Google over here. And the interesting thing is an attacker can try and do something like this. So something like a JavaScript, so something like script alert 1. But if I go back here to this particular payload, I'm able to bring this thing back into here. Let's do this here. You'll see that we're still able to go ahead and kick off something like cross-site scripting inside of this application. So what I'm going to do is I'm just going to head over to my terminal right over here, which I'm going to bring over for you to see. I'm going to kill this process. So this is the running application that's going locally. And I'm going to go ahead and install our content and query protection capabilities. So all we're doing is we're bringing the Java jars into the class path. and I'm going to go and rerun the application. That's it. So while the application is starting back up, basically what we've done is we've taken our jar files, we've put it into the class path that's able to be accessed by the actual application. So we didn't write or change any code whatsoever. It's still the same old application. And we've just got Prevoty set up to integrate directly with the application now. So there it is. The application is back up. And I'm going to head back over to the browser. It's just going to refresh this page. So if the network gods are on our side, we'll do a couple of quick tests. The first test is to make sure that the application is still behaving as expected. So you search for something like Google, and Google is still there. Do another quick test, search for another stock. And now what happens if you try something like this attack again? Prevented. That pop-up that you saw before is not executing. And if we bring that gibberish that we had before, that encoded or that fuzzed content back here again, you'll see that that didn't create a pop-up. No execution whatsoever. Now, all this intelligence gets logged, and all those logs can be pulled into any different SIM that you may have. So if you're using something like Splunk or you're using the Elk stack, we're able to give you back and share all sorts of metadata. For instance, a database query. Where in the application did this malicious database query come from? So down to the file name and the line number, which is pretty impactful, especially if you're running things like vulnerability management solutions today, being able to do the correlation of what's happening in production to what you found already. Now, the other thing that I wanted to show you is a demonstration of LANGSEC. So in order for me to do that, I'm going to try and change the display settings over here to mirror everything so you can see what I'm seeing. So let's mirror the displays. Awesome. So what I'm going to do is I'm going to show off how our science and how this technology works under the hood. This is a solution, a framework called processing. And processing allows you to visualize information. So I've just taken a content parser, and I'll pause rotation here, and I'll show off the things like tags, tag names. We're able to go ahead to web pages and view individual content blobs and visualize the relationships of nodes the same exact way a compiler would. So imagine an input coming into your application. Rather than relying on pattern matching, we can see exactly what is going to actually execute inside of a web browser before it does. So if we can see opening tags that match closing tags, if we can see closing tags that aren't opened, opening tags that aren't closed, we know the relationships of these things. And if I wanted to, I could go ahead, I could remove things like the text nodes, so you get a sense as to all the HTML is related to each other. And a full exploration over here. Again, I'm passionate about data visualization, and we're hoping to bring a lot of these visualization tools, whether it's for looking at HTTP variables or looking at database queries or operating system commands to our management console. So in the couple minutes that I have left, I'm just going to head back over to my presentation here. So I'll wrap up pretty quickly and efficiently. The goal and what we think about runtime application security is that it can really speed up development life cycles. That churn that you have right now of getting vulnerability reports, having to go in, code, fix, and go through that QA cycle takes a lot of time. And it's especially true for more legacy applications. And if you're part of a very big bank or a very big company, you may have lots of legacy apps that you've developed years ago. That original team isn't there anymore. Who's going to go ahead and fix it? Well, we think a runtime solution is really appropriate where you're not changing the application. You don't need a developer who wrote that application. You can just drop something in, which could be in a monitoring mode or in a protect mode, so passive or active mode. And again, it's stopping real-world attacks. This isn't theoretical stuff. We're sitting inside of an application. We're seeing behavior. We're seeing a SQL query that contains something like a tautology execute. And then the final piece, getting the actionable intelligence that you can use for correlation. Again, if you want to correlate it back to the vulnerability backlog, or if you want to go ahead and turn that intelligence into something for your perimeter-based defenses. So thank you very much. My name is Kunal. I'm with my colleague Jonathan. We have our booth outside. If you guys are interested in application security, please stop by. We'd love to talk to you. And if you're looking for more information about Prevoty, just prevoty.com is where you can go. Thank you very much. Appreciate it.